Hello everyone, this is Dr. Aman Sharma and I will be teaching you soil science course for the semester. Today we will be doing estimation of organic carbon, but before that I want to introduce you with the term organic carbon. So organic means it is having component of carbon, hydrogen and oxygen, and carbon, as we know, that is a gas having atomic number 6 in the periodic table. So if you just glance at the carbon cycle, why carbon is important? Carbon cycle demonstrates that carbon is used by the plants for photosynthesis, and then the processes, especially in the soil, like immobilization or carbon sequestration, are the different terms for the same carbon storage in the soil system. And when the plants die, they convert into humus, and microorganisms, they use that humus as a food for their carbon needs. So that's why the carbon is so important and vital in our system. And these processes which are being operated by carbon in soil are mainly mineralization, immobilization. In higher classes, you will be uh, having more knowledge about those processes. But today, as our concern is soil organic carbon estimation, I just want to give you a brief background that why the carbon is so important. And one more thing I want to tell you, that recently Dr. Ratanlal got the Nobel Prize, or World Food Prize, which is equivalent to Nobel Prize in agriculture, and his area of research is carbon sequestration. So carbon estimation is very important for research and teaching. Coming to the soil carbon uh, introduction, the carbon is sequestered in the soil when there is a decomposition of organic matter. The carbon becomes mobile and is available for the plants. And another major important process is photosynthesis, by which plants manufacture their own food. Organic carbon is the focal point or the hub for chemical, biological, and physical processes. Chemical processes in which the organic carbon is playing a major role is it is stabilizing the certain pH changes, and it helps in formation of complexes. It helps in immobilizing pollutants, and it binds heavy metals. For biological processes, it provides energy for microbes like bacteria, fungi, and viruses, and large storage of nutrients is important for plant growth, especially macro and micronutrients. Macronutrients, as we already know, nitrogen, phosphorus, and potassium, calcium, magnesium, and sulfur. These are the macronutrients, that means they are required by the plant in higher amounts. Another area for organic carbon is to help in physical properties of the soil. For example, it improves soil structural stability, it influences water retention. And water retention is a very important area of research these days. If there is less organic carbon in the soil, it will retain less water. That means more water should be applied to get the same crop yield. That means we need more irrigation. And then another function of organic carbon is to help reduce soil water loss from the soil system, and it buffers soil temperature as well. So that was a kind of brief introduction for organic carbon and its properties and relationship with organic matter, because we cannot estimate organic matter directly in our soil systems. We need to know certain regulators, for example organic carbon, to estimate soil organic matter in a particular soil. So coming to the experiment, for estimation of organic carbon, we need materials like weighing balance, spatula, measuring cylinder, conical flask, volumetric flask, glass rod, magnetic stirrer, beaker, reagent bottle, wash bottle, filter paper like Whatman number 1. And chemicals, we need potassium dichromate, ferrous ammonium sulfate, sulfuric acid, orthophosphoric acid, diphenylamine, and sodium fluoride. The reagents, how we can prepare those reagents in the laboratory. Firstly, for example, one normal potassium dichromate solution, how we can prepare it. So to prepare one normal potassium dichromate solution, we need to dissolve 49.04 gram of pure crystals of potassium dichromate in water and dilute to 1 liter. The second reagent, 0.5 normal ferrous ammonium sulfate solution. We have to dissolve 139 gram ferrous ammonium salt and add 15 ml concentrated sulfuric acid, and then we have to dilute it up to 1 liter. Ferrous ammonium sulfate can also be used, that's another salt, and for that we need to dissolve 785 gram of that salt in 4 liters of water containing 100 ml concentrated H2SO4. So these two reagents are the main reagents, potassium dichromate and ferrous ammonium sulfate. Then the third one is 95% phosphoric acid, and lastly diphenylamine indicator. To prepare diphenylamine indicator, we need to dissolve 0.5 gram diphenylamine in a mixture of 100 ml concentrated H2SO4 and 20 ml water. As we discussed these reagents, there are certain properties I want to emphasize for organic carbon, as I have discussed them earlier, that why the organic carbon is so important. It is an indicator for overall health of the soil. It improves the physical properties. It increases cation exchange capacity and water holding capacity of sandy soil. Especially in Punjab conditions, soils are sandy, and they are low in organic carbon. So if we want to increase the water use efficiency of such soils, we need to have more soils having more organic carbon. The next aspect is it improves structural stability of clay soils, which is very important for crops like rice. Organic carbon is a part of soil organic matter, a reservoir of nutrients and trace elements. I have already discussed that we cannot estimate soil organic matter directly, but we can estimate soil organic matter with the help of organic carbon. The other aspect is soil organic matter prevents nutrient leaching, and it is important in case of nitrogen. For example, farmers they apply urea, and nitrogen losses are very high in the form of leaching. So if organic carbon is high in the soil, leaching losses can be minimized. And other aspect like buffering, I have already discussed that in case of strong changes in pH, if a soil is having more organic carbon, it can negate the buffer changes very quickly. So coming to our topic today, about the estimation, because this is a live in class, a lab class, so I will demonstrate you how we can estimate organic carbon using Walkley and Black method. The principle of Walkley and Black method is that a suitable quantity of soil is digested with chromic acid and sulfuric acid, resulting in oxidation of organic matter. So basically it is a acid digestion of soil. Excess of chromic acid unreduced by organic matter of the soil is determined by a titration with standard ferrous ammonium sulfate solution using diphenylamine as indicator. So the reagents, as I discussed earlier, are playing a major role, like potassium dichromate, ferrous ammonium sulfate, and diphenylamine. So in Walkley and Black method, carbon, what is happening actually is carbon is oxidized by dichromate ion. So when you take soil sample in the titration flask and you are putting dichromate, potassium dichromate, soil organic matter gets oxidized, and excess dichromate ion is then back titrated with ferrous ion. So the reactions happening in that exothermic reaction, you can see from the slide that heat is evolved for first part dichromate ion reacts with carbon, and then in the second part ferrous ion reacts with dichromate for the reaction completion. So coming to the procedure of the experiment, how students can do the estimation of soil organic carbon in the laboratory. So first you have to weigh soil sample in 500 ml conical flask, and then you need to add 10 ml potassium dichromate by means of a pipette and 20 ml concentrated H2SO4 by measuring cylinder, and then you need to mix thoroughly the contents, and you need to allow the reaction to proceed for 30 minutes on asbestos sheet. So during this time, dilute the reaction mixture with 200 ml of water and 10 ml orthophosphoric acid by measuring cylinder, and then finally add 7 to 8 drops of diphenylamine indicator. Titrate the solution with standard 0.5 normal ammonium sulfate solution to a brilliant green color, and so the green color is the end point of the reaction. During this reaction, you need to run a blank as well. Students who are not aware what is blank, a blank titration means without soil. Everything will be same except there will not be any soil sample. The last step will be the calculation of organic carbon content of the given soil sample. So this was the procedure. So to give you a demonstration, I will show you how a student is performing the estimation of soil organic carbon. So as discussed earlier, now we will give you a live demonstration of the estimation of soil organic carbon. Here a student is showing the water bottle, reagent, and another reagent, and diphenylamine indicator, K2Cr2O solution. So potassium dichromate solution, that's how you all should proceed with the experiment. You should label properly the contents of the flask and then put them into tray, and then the first step is measurement of soil sample. So take a soil sample on a glazed paper. Make sure there should not be any instrumental error and weigh the soil sample properly. Now put the soil sample, which is 1 gram, into the titration flask. Now add 500 ml of potassium dichromate solution. Now after putting 10 ml of potassium dichromate solution, add 20 ml of concentrated H2SO4 with the help of a measuring cylinder. Now add concentrated H2SO4 into the 500 ml conical flask and shake it gently and put that on the asbestos sheet. And the reaction should proceed for 30 minutes. So after 30 minutes, add 100 ml of distilled water with the help of a measuring cylinder. Once this step is completed, add 10 ml of orthophosphoric acid with the help of pipette. As you can see, the student is pipetting out 10 ml of orthophosphoric acid and adding it into 500 ml conical flask. After adding orthophosphoric acid, add diphenylamine as indicator. Once you add diphenylamine indicator, the contents are ready for titration. So for titration to proceed, just take ferrous ammonium sulfate solution in a burette. So you can see you got to put that with the help of a beaker. Don't use anything else, and make sure the burette is working properly. Now just against the burette, after tightening up the screw, and then pour the ferrous ammonium sulfate from the beaker slowly and gently, drop by drop, into the conical flask. That's how you all should proceed. As you can see how the student is doing that. It should not be too fast, it should not be too slow, but a gentle titration. And at the end you will see the appearance of green color. So that means the reaction is completed and the end point is appearance of greenish color. Once you get that end point, leave the flask on one side and do all these steps for the blank reading. As I have already mentioned, in blank reading, you should not take the soil sample. So coming to the calculations part of the soil organic matter, you have to make notes of weight of soil, how many grams you have taken, and then the normality of K2Cr2O7 used, which was 1 normal, and then volume of K2Cr2O7 used for soil sample, and then two important calculations regarding how much ferrous ammonium sulfate was used for blank titration and how much ferrous ammonium sulfate was used for titration having soil sample. Once you have those readings from the burette, you will be able to calculate percentage organic carbon, which is equivalent to amount of ferrous ammonium sulfate used for blank reading minus amount of ferrous ammonium sulfate used for soil sample reading into 0.003 into 100 divided by 1 into W, where W is the weight of the soil. Now, once you get the values for organic matter, you can estimate percentage organic matter for that particular soil. And how you can do that? You can do that simply by multiplying with 1.724 factor, which is a fixed factor. How we are getting this 1.724? Let me explain you. Because on an average, organic matter has 58% carbon. So if we divide 100 by 58, we will get this value 1.724, and that's how once we have organic carbon value, we can easily estimate organic matter value of a particular soil. As I was telling you in the beginning of the lecture, that to estimate soil organic matter, soil organic carbon estimation is very important. And finally, once we have soil organic matter value, we can also calculate total nitrogen value based on organic carbon percentage value. We just need to simply multiply with 0.0862 and we can get our percentage total nitrogen. So once you get all the values for your organic carbon, you can demarcate whether your soil is low, medium or high. How we can do that? If the soil is less than 0.5% organic carbon, then the soil is low in organic carbon. And if the value is between 0.5 to 0.75%, it's a medium soil having organic carbon. And if the organic carbon is greater than 0.75%, the soil is considered to be high in organic carbon. For this procedure, you can also refer to the book by Dr. M.L. Jackson, and that is a soil chemical analysis, the name of the book, or another research paper by Walkley, who was the researcher behind the innovation of this Walkley and Black method. So, and it was published in Soil Science, which is a very much reputed journal. So with this, I complete the lecture on organic carbon estimation, and I hope you have enjoyed that lecture. And if you have any queries or questions, you can email me or contact me. Okay, bye and have a great day.